In this question, when the length of a wire is stretched n times its length, its resistance becomes n square times the original resistance. Prove it. So let's understand this question with a figure. As you see here, according to the question, we have one of the wire and its length is L and the area is A. Now according to the question, wire is stretched n time its length. So new length will become n into L. So when the length will become n into L, area will become A by n. We can understand this by a simple example of any elastic material. Let's see, here is the elastic material. So you might notice when we are stretching this elastic material, its length starts increasing. But parallelly, its thickness starts decreasing. Means initially if the length was L, if it becomes 2L, then the area will become A by 2. Means thickness will decrease. Same concept is applied it here. When the length is L and when we stretch is to N into L, the area will become A by N. So now we have to prove that new resistance will be equal to N square times the original resistance. So based on this information, we can write it as R is equal to rho L by A. Rho is the resistivity, L is the length, and A is the area. So here this R represents the resistance of the original one. Now if you have to find the resistance of this second figure, we can represent it as R dash. R dash is equal to rho L dash by A dash. Here in this case, rho is same for both the cases because same material we are using. Both has same material. So resistance is changing but resistivity remains the same. Now R dash is equal to rho, length will become N into L and area is A by N. It can be written as N square into rho L by A. And if we consider this as relation 1 and we substitute this relation here, so we can say that R dash is equal to N square into R. So this relation we had to prove that the new resistance becomes N square times the original resistance. So this is the answer of this question.